Hey everybody, I wanted to do a quick video on collimation. This particular scope here is a Newtonian reflector, and you have to make sure with the Newtonian reflector that the mirror at the back is in perfect alignment with the mirror at the front here. And the way we do that is by using a laser collimator. So I'll get one of those out. Okay, this is a laser collimator, and all it basically is a laser beam that's going straight out of this, bouncing off the secondary mirror at the front, all the way down to the primary mirror at the back, then bouncing back off the primary mirror onto the secondary mirror and back in to this target here. And the idea of this little target here is that you have to get the laser bang in the center, because if it's not in the center, then the light, which is going straight down and back up, is not traveling in a straight line because the mirrors are not all set up the same. So I'm going to put this into the telescope and then we'll collimate this telescope. Okay, so I've set up the scope, so I'll just have a quick look. Okay, so I've set up the scope so that you can see the back of the scope, and hopefully you can see the target as well. Now this is a laser, and being sort of safety conscious, I've put the cover on the end of the telescope in case it does happen to come out. You don't want it going in your eyes. So the first thing we need to do is turn on our collimator, and it has different strengths here. So currently that's on, and I can just see, I don't know if you can there, but I can just see the laser is slightly off. It's just on the edge there. So what I'm going to do, I'm going to loosen these retaining screws just slightly. They're only for locking. I've just loosened those. Now I can use these finger screws to adjust where the laser is, and you can probably see by just moving that slightly, it has moved the laser. So I'm going to move the camera a bit closer so you can have a look. So you should be able to see there that the laser is slightly off center. The laser is in the center. Now it's in the center there, and you can also tweak these ones. They do different axes, as you can see. Now I can't see the laser beam at all now. It's also really important that you make sure that the collimator is facing down so that you can see the target as you're doing your collimation as well. That's now perfectly collimated because the laser is going straight down off the secondary mirror, down to the primary mirror, bouncing off the primary mirror, back up again and back onto the target. So that's perfectly collimated. So I'm going to tighten up these locking screws. They only need to be just tight enough. That's it. So the scope is now collimated. Another thing that people ask is how often should you collimate? And the answer to that is if you've moved your scope, or if the scope has gone from very hot to very cold or very cold to very hot, the likelihood is you're going to have some movement of the mirrors. It takes, once you've had a bit of practice, it takes about 2 or 3 minutes to collimate a scope, and therefore I would probably do this every time you use the scope. If you're going to do a long viewing session, you want to get the best images you can. Also, it's best to do it just before you start because the telescope has to acclimatise to the environment if it's been inside. Therefore, the mirror has to cool down, the metal tube has to cool down, and so on. So it's really important to do it just before you start as well. So that's it, that's collimation. I hope that was useful.